All right. Section 3 review. Number 1, with a constant torque load, the horsepower varies in direct proportion to the speed. 2, with the variable frequency speed, when variable frequency speed control is used on a motor with a nameplate rating of 480 volts at 60 hertz, the voltage to frequency ratio is 8. And 3, when running a motor with dynamic braking, B, electromechanical friction brakes may be required with large slopes. I'm going to show another quick video. This one's just quick about kind of rewinding a motor. I find these interesting, but it's just going to show a bunch of the actual, like the animations are great, but it's also good to see the. No. Hold on one second. That's not what I want. That's not how I want to look. Part 1.
That's what the first person's asking.
I'll just skip through some. Count each wire inside each coil. All right, that's about as much stuff. See, just different parts and how they wind stuff. I can't imagine how much that costs.
You think buying a new motor would be.
Right, but there's so many different types of motor that are super specific to, only reason I know, like I followed the first guy or whatever on TikTok and I see all kinds of stuff and he answers that question once. He's like, everybody always asks me like, why am I filming this? He's like, I'm filming this for documentation so I can put it back together the right way, but I can also put it out there as like a TikTok. It's like so many of these motors from these factories that are 40 years old, they don't make this motor anymore. And this one motor shuts down a whole line, so they put like I can't imagine how much they pay to like get something like that back up and going.
Crazy.
But interesting stuff.
Mr. Ellis? Yeah, I'm not.
Okay, you're good. Just catch up, well, we'll have a recording to follow now, but catch up with stuff tomorrow. All right, so section 4.
Yep.
Section 4, different motor closures, designations, and operating characteristics. Hopefully everybody knows what a circuit breaker is. Continuous duty or continuous operation, something like that, that's going to be important. All these are going to be different characteristics of motor that you look for your specific purpose. Duty cycle of a motor, overcurrent protection. Most of those are pretty good. My first highlight in 410 is everything except the last sentence of that paragraph. Motors are usually designed with covers over the moving parts. These covers, called enclosures, are classified by NEMA according to the degree of environmental protection provided and the method of cooling. If the cover has openings, the motor is classified as an open motor. If the enclosure is complete, the motor is classified as an encased motor. So they have different types of open motors, a bunch of different types of open motors. In 411, I've got the sentence before the bullet points highlighted. The different types of open motors are defined by NEMA as follows. Flipping over to page 47, I've got, you need to know that the weather protected is an open motor. And then I guess above that, the third bullet point on page 47 is an online test question. Externally ventilated. This designates a machine that is ventilated by a separate motor-driven blower mounted to the machine enclosure. Online test question. Then I've got the sealed windings all the way in the bottom left highlighted. Sealed windings, an AC squirrel cage machine that makes use of a 4-wound coil and an insulation system that, through the use of materials processes or a combination of materials and processes, results in a sealing of the windings and connections against contaminants. Enclosed motors, same thing. Heading of the bullet points is highlighted. The different types of totally enclosed motors are defined by NEMA as follows. I've got explosion proof is highlighted, and water cooled are both enclosed motors. So that first one that we didn't watch, like the enclosed water cooled motor, I have never seen one of those. It seems, I don't know, it'd definitely be different. I'm trying to think of when. I guess if you can't have stuff blowing around, if you have like a sterile environment, you can do water cooled. That's it on 47. Going on to page 48, NEMA frame designation. So whenever it talks about the frame, that's like the outside, the different sizes and stuff. And NEMA has specific dimensions for bolt hole patterns, sizes, and just different components. Like we'll go through. My highlight in 420 is the sentence before the bullet points. Key dimensions are shown in figure 55 and 56. A few of these are, and I highlighted the first bullet point, distance from the motor feet to the shaft center line is known as the D dimension. So they make these so that like you don't have to have a Westinghouse or Schneider, like there's a bunch of different types of motors, but as long as you go through your parameters and everything matches up and this and the frame is the same size, you can replace it with whatever motor you want. So there's a lot of motors, especially like in the 0 to 10 horsepower range that everybody makes all kinds of motors in the 0 to 10 horsepower range, unless it gets like a water cooler or something super specific. Small machines, 421, they have different letters. Following letters shall immediately follow the frame number to denote variations. So I thought that the first, might not be in this chapter, but I've highlighted, might be in the electrical 3, but the first sentence of 421, the frame number for small machines is the D dimension in inches multiplied by 16. That's been a highlight somewhere else, so I can see it popping up as a highlight here. But as far as like the letters that follow the frame dimension, I've got G highlighted for gasoline pump motors. Medium machines, page 49, first bullet point, first sentence is highlighted. The first 2 digits of the frame number are equal to 4 times the D dimensions in inches. That's what I'm thinking about. So if that's for medium machines. Small machines, it's 16. Medium machines, it's 4. Flipping over to page 50. Motor ratings and nameplate data. You're gonna have, this is a normal nameplate of a motor. So you have all kinds of different type of settings here. So just going through this is a 5 horsepower motor. Does that work out? I don't know, like your NEMA design is your type B, and then is this for small motors? I don't know, but your like this runs at 60 hertz. Some of this stuff doesn't matter. Power factor 85.7, so this is kind of an inefficient, or 86.5 for efficiency. This isn't a very efficient motor. But you can also see the voltage that you're running at and what sometimes it says amps, a lot of times it says FLA for full load amps. And then it has your 2 different wiring types, but since a lot of times it'll show 2 different voltages. So for the lower voltage, you would wire your stuff up like this. The higher voltage, you would use this wiring diagram. Different stuff that's in the nameplate data. It has voltage, obviously. I don't have anything in the voltage section. Amperage, 432, first sentence. The first 2 sentences are highlighted. The amperage rating appearing on the nameplate indicates the current the motor will draw at nameplate horsepower, frequency, and voltage. This is typically referred to as the full load amps, or FLA. Speed, first sentence of speed is highlighted. Rated full load speed is the value indicated in RPM on the nameplate. Page 52, you need to know, I have highlighted the horsepower out to the side in figure 59. This is gonna go along with our highlight at the bottom of the page, so highlight horsepower that's kind of over here, then where you find it on the nameplate up there at the top. And that goes along with a highlight in the bottom left, all the way in the bottom left, first sentence. Horsepower is the rating used to specify the capability of an electric motor to produce mechanical power to drive a specific piece of equipment. NEMA design letters. What you need to know about NEMA design letters is on page 53, first paragraph, last sentence. About 80% of industrial motors are NEMA design B. It's a lot. Insulation class. Nothing in insulation class, but remember, like the wires that are inside these motors are not uninsulated. They have that enamel coating on them, and the more voltage, remember voltage, like if you relate voltage to water, it's what?
Pressure.
It's the pressure. So the higher voltage motors you have, the more pressure that's trying to get out of these windings, so you have to have a different insulation class. But nothing highlighted in there. Service factor 438, first sentence on 438 on page 54 is highlighted. Service factor is a multiplier for the nameplate horsepower rating that determines the amount of overload the motor can withstand. Up at the top of the page, right above 439, that last sentence up there, the most common service factor appearing on a motor nameplate is 1.15. So that's saying that that motor can withstand 115% of the normal FLA. NEMA KVA codes. You just need to know that you're gonna have a question come out of table 6 on page 55.
Test question or
Section review. Yeah, nothing important. You'll just have to refer back to that table 6. I'm not gonna talk about that too much. Bearings, I don't have anything with bearings. Power factor, I don't have any highlights in it, but that last sentence in power factor is important. The power factor is the measure of a system or equipment efficiency. Not highlighted in my book, but you should know that. You have different duty ratings and those are just based on how much you're going to use the motor and turn it on and off. I don't have any highlights in those. That's the end. You got 3 questions on page 56. Anybody know what like this picture that's been at the front of every one of these? Like this is the motor back here, but anybody know what this piece of equipment is? Yes. Air compressor. Screw type air compressor. High dollar sucker. I can't imagine how much it costs to do these cuts and stuff like that. But yeah. twin air compressor. All right, let's run through those. Number one, a NEMA designation for a type of enclosed motor is
Explosion proof.
explosion proof. Two, using NEMA frame designations, the distance from the motor feet to the shaft center line is known as the
Dimension.
D dimension, which is B. And then three, a motor with a NEMA KVA code letter of M has a locked rotor value of
D.
D. 11.1. Connections for AC motors. He did a pretty good job of talking about this in the, I think he did it in both videos, but we watched it in the first one, talking about the two different types of windings. Did he talk about having like a star delta winding where you added them together? Because you can start up in one and run in another, and using switching, you can do that, which I think this is gonna talk about. I think it'll talk about, but it's definitely out there. And that's to be able to start up with the lower amperage and then run at the lower amperage winding configuration. So you definitely need to know what delta connected motor and Y connected motor are in the trade terms. Online test question, all the way at the bottom left of the page, sentence that splits the columns, online test question. You will see that both types of motors have 9 leads and 6 coils. Online test question. The immediate next sentence is a highlight, separate highlight. In a Y-connected motor, 3 coils are connected together and 3 coils are isolated. So where he showed, like, you guys saw how many coils that guy was rebuilding that motor with, right?
Yeah.
We've kind of been learning about motors with like 2 coils, just to simplify things to kind of learn how it goes. But motors are built with numerous coils. Yeah, so you can have windings like this that extend, that have multiple coils inside of the one coil. But this is the way a typical Y motor is wired. So you have Y connected motor. 3 coils are connected together and 3 coils are isolated. So the 3 in the middle are connected together, and then 3 coils on the outside are the isolated ones. Skip a sentence, and I got the next sentence highlighted. Using an ohm meter, insulate all motor leads from one another and check for continuity between each lead. You should not have continuity between your different leads. That's a phase-to-phase short, which your motor will not work. Page 58. You need to know, up at the top, I highlighted the heading, 510 Y connected motors, and after the side of that, I wrote connected in series. So these are connected in series because there's only one path for current to flow, essentially. I've got, you can identify if a motor is wound for Y or delta, and they go through the steps on how to do that. It's a big part of the section. I never, ever had to do that. Or even thought about having to do that. It says it on the side of the motor. But you'll have some questions that are based on that. I have step 2, 3, and the first sentence of 4 highlighted on page 58. Using the diagram in figure 64 as a guide, connect the positive lead from the battery to lead 7, connect the lead from the battery negative through the normally open switch to leads 8 and 9 simultaneously. Step 3, connect one of the 3 remaining lead pairs to the voltmeter terminal. And step 4, close the normally open switch while observing the DC voltmeter. So it just goes through the steps on how to do that. I'm not going through that. I have the heading of 520 highlighted, delta connected motor, and then wrote out to the side or above it, connected in parallel. So Y is connected in series, delta is connected in parallel. First sentence of 520 is highlighted as a separate highlight. Delta connected motor has 3 sets of 3 leads. Then they go through the steps on how to find that. That's all I got for section 5. You got 2 questions. Take 10 seconds and answer those. A Y-connected motor has motors or the coils are connected in series, and delta connected motor has parallel. Section 6, NEC requirements. So you might need your NEC book for this. I think your book is going to tell you most of the stuff, but you might find the need on the test to look something up. There's a lot of articles. 430 and 440 for motors are big. 6, you know what branch circuits are. Yeah. Motor insulation, 610. First paragraph of 610 is highlighted. NEC Article 430 covers the application installation of motors, motor circuits, and motor control connections, including conductors, short circuit, and ground fault protection, starters, disconnects, and overload protection. .430 is 430 and 440. You're going to use those quite a bit. First chapter of electrical 3, you will. Top right of page 61, I've got for sentence highlighted. Any exposed live parts of motors operating at 50 volts or more between terminals should be guarded. That is, they must be installed in a room, enclosure, or location that allows access only by qualified persons, electrical maintenance personnel. Ask me questions if you have questions on a lot of this. I feel like I said, this is the little bit easier part of this whole chapter. Down below the warning, keep the following in mind when installing new motors. And then I highlighted everything except the last sentence, but I like the whole thing. Uncrating, when the motor has been carefully uncrated, check to see if any damage occurred during handling. Be sure that the motor shaft and armature turn freely. This is a good time to check whether the motor has been exposed to dirt, grease, grit, or excessive moisture during the shipment or storage. Motors in storage should have shafts turned over once a month or once each month to redistribute grease in the bearings. That's the last thing you want, is a motor to go out and then your backup has bad bearings because it's been sitting on the shelf for 10 years. So like, it's important to go spin motors to redistribute that grease, because that grease, the oil part of the grease will break out and it'll leak out from the motor. To measure the insulation resistance is a good dampness test. So that if it's kept they're kept in damp locations, you're going to have more of there's a good chance that they deteriorate on the inside. Decent chance. Page 62. You're going to have a question on the practice test that comes out of table 7 for the disconnecting means, which is the second row. So I've got disconnecting means, and then the first requirement highlighted that comes from section 430.102A. A motor disconnecting means must be within sight of the controller location with exceptions, and disconnect both the motor and controller. A lot of times this is why, like if you notice at your house, like you have a breaker for your air conditioner or your condensing unit outside, but you also have a disconnect switch that's right beside the condensing unit that you can just pull out or something like that. You have to have a disconnecting means within sight or right there. Up at the top of 63, they go through the whole, like this is a good pictorial. Did not give me that. That's a pretty good pictorial on page 63 that talks about the different parts of the wires and components going into running a motor, where they come from. I've got the absolute first one on page 63 highlighted. NEC Article 430, Part 9. Disconnects motor and controllers from circuit. Motor protection. So this is, you're gonna get into it very little in this book, but book number 3, you learn how to do motor protection. Like that's one of the harder things. Bottom right of page 64, second to last sentence is highlighted. All other motors shall be limited to 115% of the full load current. You can see at the bottom of page 64, the picture of them aligning that motor to this air conditioner motor. Whatever the driven device is, like they're using a dial indicator to make sure that the shafts are aligned. That's old school stuff. Like they've got lasers that they strap to these now that can sense the pitch and yaw, and like at least it's interesting to me just to sit there and watch them, or sit there and watch people do this stuff, because it's impressive. Thermal protectors on page 65. You're going to have 2 separate module review questions come out of the first 2 sentences. A thermal protector that is integral with the motor is often used to protect the motor from overloads and starting failures. All motors with a voltage rating greater than 1,000 must have a thermal protector, and its overload must not have an automatic reset feature. Last paragraph on the page, first sentence is highlighted. Motors over 1,500 horsepower include a device that is set to de-energize the motor when the actual temperature rise of the motor equals the rated temperature rise of the motor insulation. Branch considerations. So this is page 66. Sorry. This is like the wires that are feeding the motor. The sentence before the bullet points, all the way to the bottom left, is highlighted. Several motors or loads are permitted to be provided for on one branch circuit if. So you can power multiple motors on one circuit breaker if all of these are met. And I have the third one first, just the first part to highlight. All motors in the circuit must not be over 1 horsepower and less than 20 amps on 120 volts. So you have to, if you put more than one motor on one branch circuit, it has to follow all of those specific rules. All right, long chapter. That was still going to try to get this done today. So you've got section 6 review, module review. You've got 25 questions on page 68, 69. A little bit less supplemental exercise. Let me know. You don't have to write too much in the supplemental exercise. If you can't find some of those, ask me, and I can point you in the right section. And then I've got the practice test up here. Let's see, like by 2 o'clock, let's try to be at least finishing up. If y'all are done a little bit earlier than that, we'll go over stuff a little bit earlier. I'll just let you know right now, this is after you're done taking the test, we're gonna be done for the day. So we've got 3 hours to get this done, practice test done, and take the test. Then I'm gonna let y'all go today. Good? All right. Let me shut this recording down, and then I'll pass out the practice test.